You're fine. We're going to cover slope, intercept, point slope, shapes of graph. We're going to review powers, and we're going to talk about multiplying expressions. And we'll see if we can get all that done. Okay, so the first thing let's talk about is slope. So in dealing with straight lines, a line can be this way, it can be angled up, it can be angled this way, or let's see, it can be angled down. So those are the possible ways that a straight line can go. So it can be angled anywhere in between those. All right. So the slope is the angle as you're moving from left to right. Okay. All right. So the way we look at slope, we have to first understand how a line works. So a line has to have at least 2 points. And we call them P1 and P2. Okay, so all you need is 2 points for a line. Okay, so here we have our coordinate axis. Okay. This is the x-axis, this is the y-axis. This is the origin, which is 0. I'm just going to put a couple of points over here. This is 5. And when you make these, you have to try to make sure that they're the same. The little hash marks are the same distance. Not always possible, but to the best of your ability. So essentially, the coordinate axis is just like two number lines. One number line going horizontally, one number line going vertically, okay? And every point has two components, okay? So you have an x value and a y value. The x value is the direction and the distance you go this way. The y value is the direction and distance you go this way, okay? So in this quadrant, both the x value and the y are positive. In this quadrant, the x is positive, but the y is negative. In this quadrant, they're both negative. In this quadrant, the x is negative and the y is positive. So depending on where you are, that'll be the sign of your x or your y, okay? And it's just like how a regular number line works, right? So whenever we have a point, we make sure that we have an x and a y, and that tells us our point. So between any 2 points, there is a line, all right? So let us look at point 1 and point 2. So for point 1, we say our points are x with a little 1, y with a little 1. These are subscripts. They're not exponents. We just put them there so that we know that point 1 has x1 and y1. Okay, they don't have any value. They don't change the value. We just put them there to identify that as point 1. Point 2 would be x2, y2. Point 3, x3, y3. Point 5. So it has no real value. It just lets us know what we're talking about. Okay. So if I have 2 points, it doesn't matter what quadrant those points belong to. If I have 2 points, so I have point 1 and point 2, and I pretend like I can draw a straight line. A line will go through any of those 2 points. So every line has at least 2 points. And all we need to make a line is 2 points. To find the slope of the line, we define the slope with the letter n. I'm sure there's some sort of Latin or Greek or Arabic reason why we do that. I don't remember it offhand, but that's not important. And to find the slope, we subtract the y's and divide them by the difference of the x's. It doesn't matter, y1, sorry. It doesn't matter what order you subtract them in as long as you're consistent. Okay? So if I do y2 minus y1, then I have to do x2 minus x1. If I do y1 minus y2, I have to do x1 minus x2. So that's how we find the slope. So let's look at an example. Let's say I have a point 4, let's say point 1 is 4, 1, and then point 2 is 2 and 3. Okay. To find the slope, I would simply do this. I'd say y2, which is this one, 1 minus, I'm sorry, y2, 3 minus 1, and then 2 minus 4. Okay. All right. 3 minus 1 will give us a 2. 2 minus 4 will give us a negative 2, because remember the number line, you're at 2, you're subtracting this way. And that gives us 2 over 2 is equal to, that gives us negative 1. We could have done it the other way as well. We could have said 1 minus 3 over 4 minus 2, which would give us negative 2 over 2, which would again give us negative 1. Okay. So it doesn't really matter what order you do them in.
So either way, if we switch them, it's still going to be something.
It'll always be the same answer, yes.
Oh, okay.
So it doesn't matter which one you do it in, you just have to do it the same way. So if you're gonna put the point 2 first, you have to do y2 minus 1, then x2 minus x1. But if you want to do this one first, you just have to make sure that you do it the same way each time for the top and the bottom, the numerator and the denominator. So that's the slope. All right, any questions on that? All right, now sometimes we end up with slopes that are fractions. So let's look at that case here. Let's say I have 0.2, let's say I have 7 and 3.1, let's say I have 4 and 9. Yeah. Okay, so we have 9 minus, no, I don't want to do 9, let's do 8. We have 8 minus 3, okay, and then we have 4 minus 7. That'll be our slope. 8 minus 3 is equal to 5. 4 minus 7 is equal to negative 3. Or we could do it the other way. We could have 3 minus 8 over 7 minus 4. Okay, that'll give us negative 5 over 3. And we get the same answer because this is equal to negative 5/3, and this is equal to negative 5/3. Okay, so here's the thing. These are all the same. Negative 5 over 3, 5 over negative 3. Those are all the same. The negative can be either at the top or the bottom, or you can put it out front. Okay? We usually choose the top when we're dealing with slopes because it helps us to see how a slope works. Okay? So if we look at what a slope is, okay, so it's called the rise over the run, or the change in y over change in x. So when we look at slopes, we look at how the distance, the change, the vertical, and the change in the horizontal. Okay, so if we were to look at a line like this, we look at the change in y, this distance, over the change in x, that distance. Okay, so that's why slope is that way. So let's look at another example on a graph. So let's say I have a graph here again. Here's my x, here's my y. Here's my origin, my points. Okay, so let's say I have one of my points I use as, let's say, 3, 4. I'm sorry, 4, 3. This is 4, 3. Or over 4 and up 3. And let's say our other point is over here at, oh yeah, let's do -1 and 5. Okay, back 1, up 5. So those are our points. Let me slide this over just a hair so I don't draw through it. So my line would go through there, okay? If I'm going from left to right and my line goes down, then I know that my slope will be negative. If I'm going from left to right and my line goes up, then I know that my slope is positive. All right, so let's look here. The slope of this one is the change in y over the change in x. So we say 5 minus 3, 5 minus 3 over -1 minus 4. Okay, or we could have done it the other way. 3 minus 5 over 4 minus -1. Could have done it either way. All right. 5 minus 3 is equal to 2. -1 minus 4. Again, on the number line, we're going that way from -1, so we'll end up with -5. Okay, or we could do -2 because we have 3, we're going back 5. And this will be 5 because minus a minus will turn into plus. So we end up with -2 over 5. So let's see what that means, all right? So our slope is, from this point, we can go up 2, 1, 2, but then because that's negative, we'd have to go back 5, which would get us to here. From here, we can go down 2, because that's negative, and then over 5. So the slope works either way. You can either go this way or that way. Either way, you end up in the same place, which is why sometimes we usually put it down here just to just remember to go down, but it doesn't really matter. We can go forward and down or up and back. It doesn't really matter. Any questions on slope? Okay. All right, so let's talk about the next topic, which are intercepts. Okay, we're going to have our x's here, our y here, our origin here. So let's say I have a line that does, oops, well, we have a straight line. Okay. If we have a line that does that, it crosses the y-axis here, and it crosses the x-axis here. This is the x-axis, this is the y-axis. Wherever it crosses the y-axis, we know that we've not gone this way or this way. So we know automatically where it crosses the y-axis, x has to be equal to 0 because it's along this line. Okay, so x is always 0 where it crosses there. When it crosses the x-axis, we know that y has to be 0 because we're not going up or down. Okay? So those are our intercepts. The intercepts are the point where they cross any of the axes. okay? So what you will find, oftentimes, they will give you a point and they will say, they'll give you a line and they'll ask you what the x-intercept or the y-intercept is. So let's say I had, I don't know, 2y equals 4x plus 1. If I had something along that line, they just gave that to me. And they say, okay, so what is the y-intercept? Well, the y-intercept means x is equal to 0, which means we can do this. We know we know x is equal to 0. Y is equal to 1. We divide both sides by 2. We know the y-intercept would be 1/2, because the y-intercept, okay, where it crosses here, we know that means that x is equal to 0, okay? And if I plug in 0 for x, that means I'm left here where y is going to be equal to 1/2. So the point for the y-intercept of this line is going to be 0 for x and 1/2 for y. That'll be the y-intercept. The x-intercept, we would do the opposite. We would plug in 0 for y. So it's a little confusing sometimes because they, the y-intercept have x is equal to 0, the x-intercept has y equal to 0, so it can be confusing at times. Any questions on intercepts? Okay. All right, so let us look now at the slope intercept, or sometimes it's called the y-intercept form. And the y-intercept form is simply this: y equals mx plus b. All right, in this instance, we know this is equal to the slope, it's just a number. This is equal to the y-intercept, and it's also just a number. So that's the y-intercept, okay? So whenever you have a formula like that, where the y is by itself, the x is on the other side, that's called the slope-intercept or the y-intercept form. So if I have y equals 3x plus 4, I automatically know that this is my slope, and this is my y-intercept. Sometimes I'll have the slope in a fraction. Again, this is still my slope, and this is still my y-intercept. Okay? And we can use this to graph. So let's look at this guy and graph him. Sometimes they'll only give you this equation, and you have to graph it. Well, all right. So in this instance, we know the y-intercept is going to be -6. So that's going to be down here. We know, by definition, if the y is by itself, and we have the x here, the number that's by itself is the y-intercept. So that's going to be here. From there, we know how the slope works. The slope says that we go up 2 and then over 3. So we go up 2, 1, 2, then over 3, 1, 2, 3. So that's our second point. And then we can just draw the line. Assuming I have to draw a straight line. Okay, so from this, you can always find your graph. Okay? Any questions on y-intercept? Sometimes they'll give you a equation, something along the lines of, sometimes along the lines of this. something like, I don't know, 3y minus 2x equals 4. And they'll say, put that in the slope-intercept form, or what is the y-intercept in the slope? All we have to do is get the y by itself. So what we do is we add 2x to this side, negative 2x and positive 2x will cancel. Whatever we do to one side, we have to do the other. And that's going to give us 3y equals 2x plus 4. And that's plus because that was already a positive. We then divide by 3, divide by 3, divide by 3. These cancel. We end up with y equals 2/3 x plus 4/3. Okay? This will be our slope, and this is our y-intercept. The y-intercept does not have to be a whole number. It can be a fraction. Sometimes it is, sometimes it isn't. The thing with when you're working with math is sometimes you end up with nice expressions, sometimes you end up with terrible ones. Mostly on the KC, you won't end up with terrible expressions. They try not to do that too. Okay, any questions? All right, so that is the slope-intercept. Now the other great thing about slope-intercept is sometimes they'll give you a formula and tell you to plot points. So they may say something like y equals, I don't know, 4/5 x minus 2. And they'll say, draw that graph. Well, if you don't remember this is a slope-intercept formula, you can always just plug in numbers. And the cool thing is you plug in an x and you solve for a y. Now, most of the time they tell you to do it like this. I actually, pick an x, pick a y. I actually like to have it like this, where you put the formula here so you can see it. And you just pick the value for x, plug it in, and that'll be your y. Okay? Now you can pick any number you want for x. So for instance, I can pick a 1 here, which would be 4/5 times 1 minus 2. Then I would have to solve that equation. I'd have to do 4/5 minus 2. I'd have to get a common denominator. 2 is the same as 2 over 1. That's going to be a 5. That's going to be a 5. That one's going to stay the same. 1 times 5 is 5 times 5, 10/5. 4 minus 10 will give me negative 6/5. So that'll be that. But I don't want to have to graph that, because that's okay. I can pick any value I want for x. So I'm going to pick values that make my life easy. Okay? I can pick the intercept itself. I can say, let me pick 0 for x. So now I have 4/5 times 0 minus 2. 4/5 times 0 is 0. That's easy to graph. 0 comma negative 2. So I can pick that. I can pick any number I want. I can pick 10 million if I want. I wouldn't want to do that. The next number I can pick, I can say, well, if I pick a multiple of 5, then that denominator is going to cross out. So I'm just going to pick 5. So 5, I have 4/5 times 5, which is the same as times 5 over 1, minus 2. That's going to give me, my 5 goes into 5 one time, goes into 1 time. So I'll end up with 4 times 1 is 4. 1 times 1 is 1, 4 over 1. 4 minus 2 is equal to 2. Again, easy to graph. I can graph this. 0 and negative 2, 5 and 2. I can graph that rather easily because I can just plot points. And I only need 2 points to make a line, so this is what I'll do. So again, you can choose one and have to figure out where negative 6/5 is, or you can pick numbers that just make your life easy. So just pick a number that makes your life easy. Pick a number that cancels the denominator, and pick 0 whenever you can. And that way, you have nice points to graph as opposed to these points. Does that make sense? Okay. Now sometimes they will give you two points and ask you to find the line. okay? And that is called the point slope form. The point slope formula is this. We have a variable y minus point y1 is equal to m x minus x1. Okay. In this instance, this is a number, this is a number, this is a number. These are just variables. So let's look at an example. Let's say point 1 is 2, 5. Point 2 is 3, 3. Okay? All right, so the first thing I have to do is I have to calculate my slope. So m I'm going to do 5 minus 3 over 2 minus 3. And again, we could have done it the other way as well. Okay. That's going to give me 2 over -1, which is equal to -2. That's my slope. And then I'm just going to pick point. Now, this says y minus y1, x minus x1. It could just as easily be y minus y2, m x minus x2. It doesn't really matter whether we use this point or that point, as long as we use the same point. So our formula then will be y minus y1, which is 2, equals m, which is -2, times x minus x1. I'm sorry, this is y1, it should be 5, sorry. It should be 5. That should be that. So y minus y1 equals -2x minus x1. Okay? And that gives us y minus 5 equals -2x. We have to distribute this. -2 times x gives us -2x. -2 times -2 gives us +4. Okay? We have to add the 5. Add the 5. We end up with y equals -2x plus 9. So we started off with 2 points, and they tell us to create the equation, and that's called the point slope form. So they don't provide formulas on the KC. So the formulas that you are going to have to remember are the slope, y-intercept, and the point slope. So those you have to remember. Any questions? All right. So those you're just going to have to remember. All right. Okay, so quickly we'll go over the shapes of a graph. Okay, so whenever you have a quadratic or a second power, you'll have something like y equals x squared minus 1, or y equals 3x squared plus 2, or y equals x minus 1 squared minus 1, something along that line. If you have the y by itself and you have an x squared term, you're going to end up with a parabola. And a parabola simply is something like this. It's like a letter U. Now, the letter U can be in different places. It can be over here, it can be over here, it can cross the line here, it can be over here, it can be over here, it can be up here. the shape will always be the same. Essentially, you have two arms pointing up. Okay? So they may ask you, they may give you a graph, and they may say something to the effect of, you got this guy, you got this guy, you got this guy, and you got this guy. And they'll say something like, which one of these is this formula, y equals x squared plus 1 or something like that. You know it's not this because it's a straight line. This is actually absolute value. This is the third function. We'll talk about that in a second. So your answer would be this because it looks like a U. So you just have to know that a parabola has both arms up. All even number functions or equations have them up. So y, x to the fourth, they both go up, but it looks more like a W or something like that, I don't know. Odd numbers have one up and one down. So like the third power has, it looks like this. Well, not exactly like that, but like this. One arm up, one arm down. Okay. So just so that you know, even powers, both arms go up, odd powers, one arm up, one arm down. And that's just a good rule of thumb. There are not too many questions like that on the KC, but just so you know. Okay, so, all right, let's review powers. In an earlier lesson, we talked about the powers, which was a to the m, a to the n equals a to the m plus n. If you weren't here for this lesson, you can look on our YouTube channel and you can find the entire lesson, a to the m divided by a to the n, a to the n minus n, a to the negative m, 1 over a to the m, 1 over a to the negative m equals a to the m. Okay, so essentially, if I have two numbers or two variables, the base is the same, and they have different exponent, and I'm multiplying them, I can add the exponents. If I have something raised to a power and I raise that to a power, I multiply the exponents. If I have a base raised to a power divided by that same base raised to a different power, I subtract the exponents. A base raised to the negative, we can move it to the denominator and make it positive. Same thing here, if we have a base raised to a negative power, we can move it to the numerator and make it positive. Okay? So these are just powers. These are things you're just going to have to know. Now they won't ask you this particularly, but they may give you something like this. They may say 6x squared, y to the fourth, z to the third, times 2x y to the second z. And they want you to solve that. And what we do is we just multiply numbers by numbers, bases by bases. Okay? So 6 times 2 will give us 12. X squared times x, remember there's an invisible 1 here. We have to add the exponents. That'll be 2 plus 1, x to the third, y to the fourth, and y to the second power will give us y to the sixth. Z to the third, and z, again there's an invisible 1 there, will give us z to the fourth. So they may give you something along this lines where you have to multiply the expressions. And we just do the numbers by the numbers, and then the variables like that. Now we also can have something that's very similar. We can do division. We can do 8x to the third, y, z to the fourth, divided by 3x, y to the fifth, z squared. Okay? And so to do this, same thing. We just look at them together. Everybody got this one? Okay. And in this instance, 8 divided by 3, well, there's nothing we can do about that. That's going to stay 8 over 3. Okay? X to the third divided by x, the same as x to the 1. When we're dividing, same base, we subtract. That'll be 3 minus 1, or x squared. Okay? Y, which is the same as y to the 1. Y to the 1 minus y to the 5th will give us y to the negative 4th. Z to the 4 minus z squared, divided by z to the second, we subtract, we get z to the second. And notice here, we've got this to the negative, which means that we can move it to the denominator and then it will become positive. So we end up with 8x squared z squared over 3y to the 4. It became positive because we moved it from the bottom, and from the top as a negative to the bottom, and it became positive. So you'll be multiplying expressions. And generally, it's something along this line. They may get complicated and put some of them together along this line. You may have something like, we'll do a different color. You may have something like this, 2xy to the third over 5x squared z times, let's see, 6y z to the third over 4y, no, x, y, z, something along that line. And you can do a lot of cross multiplying, but I don't recommend doing that because it gets kind of confusing. Everybody has this one down? It gets kind of confusing. So I would do it, simplify what you can vertically first, and then do it again, and then combine it, all right? So this is x to the 1. So we know we're going to end up with 2/5, 2 over 5. We're going to have x to the 1 minus 2, which gives us x to the negative 1. But we know x to the negative 1 can go down here in the denominator. The y doesn't have anybody to cancel with, so he's going to stay the same. And the z is going to stay the same. So I simplified that one as best I can. All right. Now let's do this one. 6 and 4, I know from fractions, my review on fractions, that I can reduce that. I can divide 2 into both, right? So 6 divided by 2 will give me 3. Okay. 4 divided by 2 will give me 2. Right? I've got a y here and a y here. They have the same value, so they're going to cancel. I have a z to the third and a z. That's going to give me z to the second, and then x. Okay? Right? Now I can start to look to see, okay, are there things that I can cancel? Okay? Because we know that multiplying, if we're multiplying it, it works the exact same way. All right? This is the next. Okay, so we know that this 2 and this 2 will cancel because 2 goes into itself one time. Okay? We have a z to the 1 here. Okay? Z to the second divided by z to the 1 will give us z. Okay? So we end up with 3 going to be here. All right? There's nothing to cancel our y, so he's going to stay the same. Our z to the 1 and z to the 2, that would give us a z. 5 has nothing to cancel, so he's going to be here. And then we have x, which is the same as x to the 1, times x to the 1, which will give us 5x squared. So in this instance, we simplified as much as we could here and here before we started doing the cross stuff. Otherwise, it gets too complex. So you want to make this simple, and then you can treat them as one problem. Any questions? All right, well, that is it for today. Thank you very much. No questions? All righty. Covered that rather quickly. Awesome. Awesome, awesome, awesome.